All right, guys, so we're looking at some more quadrilaterals. So they have four sides, but these are not parallelograms, okay? So these do not fall under the same parallelogram rules that we have looked at the last couple classes. These are kind of a completely separate brand of shapes. So first, let's look at trapezoids, okay? So trapezoids, we call these a set of base angles, and this is a separate set of base angles. So the bases are the parallel sides. So what makes a parallel or a trapezoid is if there is exactly one pair of parallel sides. Okay, so trapezoids have exactly one pair of parallel sides. That's what makes them different from a parallelogram. The parallelogram has two sets of parallel sides. A trapezoid only has one set of parallel sides. Okay, so if you look at a single parallel or one of the parallel sides, those are called the bases. And then with one of them, the two angles on either side of that parallel line are one set of base angles. The angles on the ends of the other parallel line are the other base angles. And then we call the two non-parallel sides the legs. All right. So we know that there's exactly one set of parallel lines in a trapezoid. The second rule is this right here. Okay. So this rule right here. So essentially what that's saying is the mid-segment. I need to switch to the pen. Sorry, let me grab my stylus really quick. Okay. Okay, so the mid-segment is the average of the bases. Okay, so we have the mid segment, so let's kind of color code here. So the mid segment is this one right here. So it is parallel to the two bases. Oh, geez. Sorry, it didn't group together. Hold on a second. Group. Okay, there we go. So this mid segment right here is parallel to the two bases, and it's exactly halfway down each of the legs. So exactly halfway down each of the legs. So it bisects the two legs, okay, and then it is parallel to the third side. That's called the mid segment, okay, and it's the average. So essentially, what you do is you add up the one base plus the other base and divide by two. That would be averaging them, and that should equal the mid segment. So that's the only rule that we have for trapezoids, regular old trapezoids. Now realize that kind of incorporates several different things. If this is a mid-segment, it bisects these two sides. So if I know what this is, I know what this is. Same thing over here. I know that it's parallel to the other two sides, and then I have the average rule, okay? So then if we get into something called an isosceles trapezoid, there are several more rules that go with an isosceles trapezoid. So the only thing that makes an isosceles trapezoid isosceles is this right here. So the two legs are congruent. Okay, that's what makes it isosceles. The legs are congruent. Okay. All right, so if the legs are congruent and we have an isosceles trapezoid, there are several other rules that we can look at. Okay. So the base angles are congruent. That's what this is telling me. Okay, so the base angles are congruent. So you can see that A and D are one set of base angles. That means they're congruent. B and C are another set of base angles. That means they're congruent. Now, if these two are congruent and these two are congruent, we also know these two have to be supplementary. So let's put that in here. Another little rule. A plus B. So angle A, sorry, let me put the angle markers in there. Angle A plus angle B equals 180. They're supplementary, okay? Same thing with C and D. C and D would add together to be supplementary. Okay, we have our base angles converse. So if you have a trapezoid and you see that the base angles down here are congruent, then you can say that it's isosceles. That's not going to come up a whole lot, but it's one of the rules that we have. Okay. The diagonals of an isosceles trapezoid. So again, only if it's isosceles, right? Only if it's isosceles, the diagonals are congruent. Okay, so BD is congruent to CA. And again, that's only if it's isosceles. Okay, so we have some rules for regular trapezoids. We have some rules for isosceles trapezoids, and then the last one is diamonds, kites. Okay, so a kite is a kite if it has two sets. Let me go ahead and write this. Two sets of consecutive. Okay, so consecutive, congruent sides. Okay, so two sets of consecutive congruent sides. So we've seen, remember with parallelograms, we had two sets of opposite congruent sides. Well, this is different. This is consecutive congruent sides. So this word right here is very important, right? So consecutive congruent sides. So some rules about kites. Their diagonals are perpendicular to each other, so they meet at a right angle. I will also say, this sheet doesn't say it, but I do want to throw it out there, okay? The big diagonal, the long diagonal, always cuts the small diagonal in half. Okay, so the big diagonal bisects the small diagonal. So I can say that the pieces of the small diagonal are congruent to each other. Obviously, the big diagonal is not bisected, but the small diagonal is bisected by the big one. Okay, so that's another rule that we have in there. And then we have the kite opposite angles theorem. Okay, so the let's see, the angles that are across from the small diagonal, so this would be my small diagonal, right? Okay, the angles that are across from that, C and A, are congruent. Okay. So if it's a kite, then the angles across from the small diagonal are congruent to each other. So the small diagonal is bisected, and the angles across from the small diagonal are congruent. Okay. All right, let's go to the second page and look for symbols here. All right, so looking at number 2, okay? So we want to find the value of x and then find EH, okay? So again, just like I have on the previous examples or on the previous note pages, I'm just going to set up the equations. I'm not going to take the time to solve them, okay? So my mid segment, so this is just a regular old trapezoid. So my mid segment of 3x minus 2 should equal the average of my bases. So I would take x plus 11, and I would add to it 3x plus 3, and then I divide by 2, or that's the same as multiply by a half. Okay. So then that's my equation. So I could use that to find x, and then in order to find EH, right, I would just take whatever x value I get from this and plug it in for EH, which is my 3x plus 3. Okay, so that's number 2. All right, let's scoot over to number 3. So we have a kite here because I have two sets of consecutive congruent triangles. Okay. All right, so we want to find the value of x and find the length of JE. Okay, so find the value of x first. So remember we said with a I keep wanting to call it a diamond, with a kite, the small diagonal is bisected, so that means 9 should equal 1 over 10x minus 1, okay? So I am going to go ahead and solve this because we have this little extra piece back here. So let's first find x. So I add 1. So I have 10 equals 1 over 10x. Remember, to get rid of a fraction, you multiply by the reciprocal, so 10 over 1. So it's just x equals 100. Okay, so I know x equals 100. Then it wants me to find JE, so I'm finding this side right here. If HE is 25. I'll switch to the pen. 25. Okay. So this should hopefully trigger in your brain. Remember, diagonals are perpendicular to each other. So we should see this right triangle forming. Okay. Remember, with right triangles, we can solve for one side with the Pythagorean theorem. So remember, the C is always opposite the right angle. So C is my 25. So 25 squared equals A squared. So I'll just say 9 squared plus B squared, which I don't know. Okay, and then I can solve that for B. And I know that B is the same as JE. So once I find B, I have my answer there. Okay? Alrighty, let's keep going here. So let's look at number 4. Okay, so number 4, I know this is an isosceles triangle, right? I know this is an isosceles triangle because of the congruency markers on the legs. Okay, so we have an isosceles triangle, and I know that base angle should be the same. So if this is 51, this should be 51. Okay, and then remember we said that one angle from each base should be supplementary, right? So these two are congruent, these two are congruent, these two are supplementary, okay? So I know that 28x minus 11 plus the other angle of 51 should equal 180 degrees, okay? Because it is supplementary, and then you can solve for x from there. All right, let's keep going. Number 5, okay? So this one doesn't actually write it on here, but it should. So it's missing the congruency markers here. There's no way we can solve this unless it's isosceles, okay? So then we know that these two should be supplementary, right? So 6x minus 22 plus 8x plus 34 should equal 180 degrees, okay? So that was the same as number 4. All right, let's keep trucking here. Number 6, okay? So it says U is 119, okay? So 119. It says W is 61. It says V is 3x minus 4y, okay? And it says X is 2x plus y, okay? Alrighty, so I'm going to have to set up a couple equations here. So remember that, so S and T are kind of unneeded here, right? I know that base angles should be congruent to each other, right? So base angles should be congruent to each other, and this set of base angles should be congruent to each other. So those are going to be my two equations. So I have 2x. Let me change colors because that'll get a little confusing. Change this to the blue. So 2x plus y equals 61, right? Because those are congruent. Second angle from my top base angles, 3x minus 4y equals 119. Okay, so remember, again, I'm not going to solve it, but you guys should take the time to practice your systems. So remember, we're probably looking at an elimination here. 2 and 3 I don't like to mess with, but 1 and negative 4 would probably work out pretty nice. I multiply this top equation by 4, so I have 4y and negative 4y that I can cancel out and eliminate and keep going from there, okay? All right, last but not least, number 7. Okay, so it tells me U is x squared minus 8x, and x is 160, okay? So again, I know that these are supplementary. So I set up my equation, x squared minus 8x plus 160 should equal 180 degrees, okay? So this is, again, testing your algebra skills a little bit. This is a quadratic, right? I have an x squared in there, so we're going to have to call back on our algebra skills, probably do a little quadratic formula, or factoring. I don't think factoring would work. Okay, so I'll just go through factoring. If you want to do quadratic formula, you can look that up. I'm just going to go through factoring really quick though. So remember, before you can do quadratic formula or factoring, you have to get it equal to 0. So that's what I'm going to do first. So I'm going to subtract 180. Okay, so then I have x squared minus 8x, let's see, minus 20 equals 0. Okay, so at this point, if you want to do quadratic formula, I'll just put it up here, quad form. Okay, you would do a equals 1, because that's the number in front of x squared. B equals negative 8. Whoa, that's ugly. Negative 8, there we go. And C equals negative 20. And then you can look up quadratic formula if you need it. Okay, but I'm going to factor here. Okay, so remember, factoring, when I do not have a number out in front of x squared, it's what multiplies to C and adds to B. So if I bring negative 20 over here to the side, I can look at factors. So I have negative 1 and 20, 1 and negative 20. Neither one of those adds to negative 8. I got negative 2 and 10, 2, and negative 10. And 2 and negative 10 add to negative 8. So I know that it's x plus 2 for the positive 2, x minus 10 for the negative 10 equals 0. And remember the zero product property, so I know that for the whole thing to be 0, either that piece has to be 0 or that piece has to be 0. So this would be x equals negative 2. This would be x equals positive 10. And let's see, what would happen if I put either one of those in there? See if one of them might not be right. So if I plug a negative 2 in, it's going to be a positive answer. If I plug a 10 in, it's going to be a positive answer. So both are good answers, okay? So I could use either of those as my answer, okay? All right, time to work on practice, and I will see you guys next class.